This video, we'll explore the different properties of the square. I like the square. The square is kind of a special fella in that he is both a rectangle and a rhombus and a kite. What's not mentioned here is that he's also a trapezoid because his base angles are congruent. He's an isosceles trapezoid, and he's a parallelogram. So I'm going to go ahead and I'm going to add those things in here right now, and a trapezoid. An isosceles trapezoid, and a parallelogram. And what I like about this is because he belongs in all of those categories, all of the properties of those different quadrilaterals always apply to the square. So you don't need to remember it has that, but it doesn't have this, or it has this, but it doesn't have that. The square has it all. So that's, again, kind of a nice way to remember the square has it all. He's got all the properties of the parallelogram, he's got all the properties of the trapezoid, he's got all the properties of a rhombus, all the properties of a rectangle, so on and so forth. All right, so let's go ahead and see how we could use this in order to solve some problems. In example 1, it says that we're given square ABCD with side AB equal to 2x minus 14 and side BC equal to x plus 15. They want us to find the value of x and the length of a diagonal of the square. All right, so I'm going to go ahead and set up my picture. And recall that when you label the vertices of this picture, you either have to go around in clockwise or counterclockwise order. I'm going to go around and label the vertices clockwise. So side AB was 2x subtract 14, and side BC was x plus 15. So in order to solve for x, you're going to need to remember that in the square, the lengths of all the sides are equal. So all four of these sides have the same measure. So in other words, the length of side AB, 2x subtract 14, is equal to the length of side BC, x plus 15. So now I'm going to go employ my algebraic magic here and solve this equation. And I find that the value of x is 29. So the first task that we were given here in this problem is done. The next task is going to be even more fun. We want to now go find the length of a diagonal. So I'm going to go ahead and I'm going to draw my diagonal in there, and it doesn't matter which one you draw because both of them will have exactly the same length. The square is a rectangle, and as you know, one of the properties of the rectangle is that it has congruent diagonals. So I'm going to call that y because I already used the variable x. And if I know that the value of x is 29, then I know by substituting that in that the length of side BC is 44, and the length of side AB is 2 times 29 minus 14, or 44. And because we're working with a square here, all sides, remember, are the same. So if one side is 44, then all the sides have to be 44. And what I want to focus on to solve the second part of this problem is I want to think about that triangle. And again, it really doesn't matter which triangle you pick. I could have picked the one up at the top, triangle ABD. It would have been the same triangle because the dimensions would have been exactly the same. But I'm going to pick that one in the bottom right-hand corner. This triangle I know is a right triangle because in the square all of the angles are right angles. I know 2 out of the 3 side lengths for my right triangle. And when we know 2 out of the 3 sides in a right triangle, we use Pythagorean theorem to find the length of the third side. So this now becomes an a squared plus b squared equals c squared problem, or 44 squared plus 44 squared equals the hypotenuse, y, squared. And when I go to get my calculator out, and you should get your calculator out too to double check my math, I find that the sum of 44 squared and 44 squared is 3,872. And now when I solve for y by taking the square root of both sides, I find that the value of y is the square root of 3,872. And so now comes the fun part of this. Now I get to simplify that radical. And this looks a little scary, it looks a little intimidating, but I'm going to give you a tip that'll change everything. As long as you remember that when you're simplifying the radical, always try taking out a factor of 2 first. This should be a relatively simple and painless process. So my tip here, when you're simplifying the radical, try dividing by 2 first. Because that trick of dividing by 2 first will always make this less complicated. Because when I divide that 3,872 by 2, the result I get is 1,936. So I'm going to rewrite this radical as 1,936 times the square root of 2. So again, all I've done is I've taken that 3,872 number and rewritten it as 1,936 times 2. This is super helpful because again, if you get your calculator out, that number underneath the square root, that 1,936 number, he's a perfect square. When I type that into my calculator, I find that the square root of 1,936 is 44. I can't simplify the square root of 2, so I'm merely going to leave it as square root of 2. So the length of that diagonal now is 44 square roots of 2. Beautiful. All right, I'm going to move on to number 2 and see what goodness lies in store for us here. This one says, find the length of the side of a square whose diagonals are 12 centimeters. So this is a little different than the first one because in the first one we were trying to find the length of the diagonal. And in this case, we know the length of the diagonal. I'm going to start out with my square. And I'm only going to draw one diagonal in just to keep the picture a little bit less complicated. I know that if I were to draw the second one in, it would have exactly the same length. But again, I'm trying to keep this picture as simple as possible. Because this is a square, I know that the lengths of all my sides are the same. I know that this diagonal has measure of 12 or 12 centimeters. The length of the side of the square is what I'm looking for. I'm going to call that x. And remember, if one of them has length of x, they all have lengths of x because the square has sides that are all the same. So like the first problem, this one too is simply a Pythagorean theorem problem, but this time my hypotenuse I know, whereas in the first example the hypotenuse was what I was trying to find. So again, it becomes an a squared plus a b squared equals c squared. In this case, my two legs are each x's. And I actually know c, so I'm going to go ahead and substitute that in. C is 12. So we end up with 2x squared is equal to 144, or when I divide both sides by 2 in order to isolate the x squared, I find that x squared is equal to 72. So x must therefore be the square root of 72. And when simplifying this radical, I'm going right back up here to this tip, going right back up to this hint, because when you're working with squares, that tip is super helpful. So when I divide the 72 by 2, I find that 36 times 2 is 72. So I'm going to rewrite that number as the square root of 36 times the square root of 2. And then, of course, the square root of 36 I can take. Square root of 2 I can't. So that length of one side of the square now becomes 6 square roots of 2. But again, that tip, super helpful anytime you're working with the square. All right, number 3 is a lot like number 2, but I'm going to show you an alternative strategy that you can use. So if you didn't particularly care for the strategy that I used in number 2, this one will give you a different strategy that you can use. The objective is still the same. We're trying to find the length of the side of the square when the diagonal, in this case, has a measurement of 16. In this case, though, I'm going to do something a little bit different, and I am going to put both diagonals in my square. And I'm going to remember that a square is a rhombus, and that in a rhombus, the angles that are formed by the diagonals are all right angles. A square is also a parallelogram, and one of the properties of the parallelogram is that the diagonals bisect one another. So if the length of the entire diagonal is 16, and they bisect one another, that means that each piece of each diagonal must be 8. And now in this problem, I'm going to isolate any one of those 4 isosceles triangles. It doesn't matter which one because they're all congruent. I'm trying to find the length of that side of the square, so I'm going to label that x. And as you might have expected, this one too is going to become an a squared plus a b squared equals c squared. In this case, my 2 legs, my a and my b, are each 8. And my hypotenuse, my c, is what I'm looking for. So again, don't take my word for it. Go plug 8 squared plus 8 squared into your calculator. But when I did those computations, I found that 8 squared plus 8 squared was 128. Taking the square root of both sides lets me solve for x, and I find that x is square root of 128. And again, I'm going right back to that helpful tip. Any time I have to simplify that radical, I'm always going to try dividing by 2 first. So I find that 2 goes into 128 64 times. So again, I'm going to rewrite that square root of 128 as root 64 times root 2. I can take the square root of 64, so that becomes 8. I can't simplify root 2, so it says root 2. So the length of that side of the square then has to be 8 square roots of 2. All right, if you have questions about this, feel free to ask away the next time that you come back to class. It might be helpful to write them down now so that you'll remember to ask. In the meantime, see what you can do with those key ideas and then check your understanding on the next page. And I'll look forward to seeing you the next time we come together and meet.